10 browser APIs you probably don't know exist. 1. The Web Authentication API. Most people access the web these days with a mobile device, and you'll get more people to use your application if you make life easier for mobile users. But login screens can be awful on a mobile device because you have to type text into multiple fields in a form. It would be much better if people could log in with a fingerprint or a Face ID. You can do exactly that with the Web Authentication API. You'll need code in your server, and you'll also need some code in your browser. Let's have a look at the browser code first. We begin by sending a user ID to the server. This represents the person who owns the phone, and you'll probably store the details in a cookie. The server finds the public key for the person's fingerprint sensor, which had previously been registered against their account, and it sends back a thing called an assertion to the client, which is like a math problem which can only be solved with a private key. The client generates its response using the fingerprint sensor. Here we're using GitHub's Web Authentication library. If the fingerprint sends back a valid response, the user is then logged in. 2. The Background Sync API. Talking of mobile users, when people are on the go, they will frequently lose their network connection. That can really mess up your application because the data they send your server can just be lost. To get around that, you can use the Background Sync API. Background Sync will queue up data that you send to the server and resend it later when the browser has a connection. Let's say your browser code makes a post request to the server when it's offline. You can use the Background Sync API in a route in a service worker that will intercept the request and add it to a queue. Here we're doing this with a service worker created with the Workbox library. If you've never used a service worker, then you can think of it as kind of like a proxy server that runs inside the browser alongside your application. That failed network request will remain in the queue and will be resent to the server when the network and the server are available again. 3. The Cache API. Networks are not only flaky, they often have very limited bandwidth. If your application has a lot of images or other content that it has to keep reading from the server, that will totally soak your bandwidth. You can massively reduce this problem with the Cache API. The Cache API allows you to programmatically control which files are stored locally and which are read each time from the server. You can use caches direct from a service worker. With a cache-first strategy, you can load resources from local caches first before checking to see if they've been updated on the server. This means that images, fonts and style sheets can become instantly available, and if your user refreshes the page, it will reload just as quickly as if it was a local file. 4. The Beacon API. Sometimes you might want to send information to the server at the end of a user session. It might be analytics data, or you might want to persist some work that's in progress. But if the session is ended because the user has left the page, then any normal network requests using the fetch function will be cancelled. That's what the Beacon API is for. The send beacon function is guaranteed to complete even after the user has left the page. You can call the send beacon function when the visibility state of the page becomes hidden. The WebSockets API. People use your application to get access to the data it contains. But what if the data on the web page gets out of sync with the server? WebSockets allow the server to tell the browser when important changes have occurred. A WebSocket is an open connection to the server, and it's built on web worker infrastructure. On the server, you write code that will run when the browser makes a WebSocket connection, and now if something important changes on the server, the browser can be immediately informed and make whatever calls it needs to get itself back up to date. 6. Background fetch. Sometimes a user will want to download and use files offline, but downloading large files like podcasts and videos can take a long time. If you use the background fetch with the Cache API, your application can then use those large files even when the user is completely offline. That means that you can use background fetch, for example, to create a podcast player which can download episodes and play them without a network connection. 7. Offline network detection. Talking about the network being offline, what if some parts of your interface absolutely require the user to be online? Well, if you create code to listen to online and offline events, you can update your interface dynamically so that the user doesn't try to use a feature when it's not available. You can register listeners to window online and offline events to track when a network connection is available. If the browser doesn't support the Add Event Listener function, you can simply create online and offline event handlers on the body object. 8. The Web Speech API. What if you want to provide audio feedback, or if you want to simulate how your application might work with a screen reader? How can you generate speech? Do you need to create a whole set of audio files and download them from the server? No. You can use the Speech API. The Speech API is built into most browsers and lets you turn text direct into speech. You access the speech synthesizer with the speech synthesis attribute of the window object. You can check if the synthesizer is currently speaking and cancel it. Then you can get it to read a new piece of text by passing a new speech synthesis utterance object. You can easily use it to create a simple screen reader to get some idea of how easy or hard it will be to use your application without a visual display. 9. Two-factor authentication with the Web Authentication API. Security! Everyone loves security, and most third-party security systems come with the ability to add two-factor authentication. But what if you want to add two-factor authentication to your own security code with something like a YubiKey? Well, the Web Authentication API we use for fingerprint and face detection can also be used with external security tokens like YubiKeys. A user can register a YubiKey against their account, and the next time they try to log in, they will be asked to also tap on the YubiKey to prove they are who they say they are. The code uses the same Web Authentication API as we used with the fingerprint sensor. The real difference is that the server login endpoint now has the additional ability to delay logging a user in until the physical token is applied. We could use two-factor authentication with a built-in fingerprint or Face ID sensor, but it's probably not a good idea because we'll only be able to log in then from a single device. USB security tokens like YubiKeys are much better because you can take them with you and use them wherever you like. 10. A service worker CatchHandler. Finally! What if your network dies when you're halfway through rendering a page? What will happen to all those thumbnails and images your user is browsing through? You can fix that problem with offline replacements. Service workers can automatically detect when a network is offline and redirect requests for images to locally cached placeholders. If you're building a service worker with Workbox, you can create offline replacements with a CatchHandler. It's like an exception handler. It's called whenever a network error occurs. You can check if the file is being loaded from an HTML image tag and then return a placeholder image from a local JavaScript cache. Do you have a favourite browser API that's rarely used? Put them in the comments below. Many of the examples we've looked at here come from React Cookbook by O'Reilly Media. A link to the book and the source code is available in the description.